Welcome back to the Deep Dive. Today, we are taking a bit of a shortcut. We're going straight to the source, but maybe one of the driest sources imaginable.
Right.
The product page for the NTI E-BEEP1-1000. It's a rugged miniature piezo alarm.
It sounds incredibly technical, but really our mission here is to translate those specs into, well, actual knowledge.
Exactly. Most of us think of a piezo alarm as this tiny, almost fragile thing inside a computer. We're going to figure out how this specific model just completely flips that expectation on its head.
It's all about how resilience can be a force multiplier for security. The tiny size is really deceiving.
Let's start right there with that paradox.
Yeah.
We're talking about an alarm that is miniature, what is it, just 1.3 by 1.15 inches?
Tiny.
And yet it's rated to blast out sound at 95 to 103 decibels at 2 feet. I mean, that's subway level loud. It's genuinely uncomfortable.
It's a real deterrent, not just an alert.
Yeah.
But the question is, how does something so small and so loud not just, shake itself apart?
How does it survive a real beating?
And that all comes down to the construction. When they say rugged, they really mean it. The internal parts are completely sealed off.
How?
It's done with this heavy epoxy encapsulation. So the electronics are, well, they're basically entombed in this protective shell. It also gives it polarity protection.
Okay, so that kind of sealing, that suggests serious resistance to things like moisture and vibration, right?
Absolutely. And you don't have to guess. The proof is right there in the compliance ratings. Has two really crucial ones, IP68 and ASTM B117.
Let's break those down. IP68. I think most people have seen that on their phones now.
Right, but this is a bit more extreme. The 6 foot means it is totally, completely dust tight. Nothing gets in. The 8 foot means it's protected against continuous submersion in water.
Continuous. So you could literally drop this in a puddle or an industrial tank and it just keeps working.
It keeps shrieking, exactly.
Wow. Okay, what about the other one? ASTM B117. I don't see that one on consumer electronics.
No, not usually. For you listening, that's the standard that confirms its extreme resistance to salt spray, corrosion,
Ah, so you could deploy this near the ocean or maybe in a chemical plant?
or even just very high humidity environments. And this resilience works across a really monstrous temperature range, too. It's happy from -4 all the way up to 149 degrees Fahrenheit.
So it can be submerged, frozen, and practically boiled. Which brings up the next question.
Mm-hmm.
How do you connect it? How far away can you reliably put this tiny, indestructible sound bomb?
That is the other half of the puzzle.
Because running a low-voltage DC signal 1,000 feet, I mean, that usually requires really heavy wire, maybe boosters, to fight voltage drop.
And that's the key technical hurdle they solved. The input voltage is pretty standard, 5 to 15 VDC. The magic is in its current consumption. It is incredibly low.
How low?
Just 50 milliamps at 12 volts. It barely sips power.
So that low current draw is the secret weapon. That's what lets the signal travel so far without degrading.
Precisely. That minimal draw is what allows the power and the signal to stay stable over the maximum 1,000 feet. That's over 300 meters. And it does it with just a simple 2-wire interface.
So you could wire up a massive warehouse or an entire perimeter fence with these things.
Without any complex setup.
I also noticed it's TAA compliant. In this kind of industrial context, what does TAA actually mean for a buyer?
Well, TAA compliance means it meets the Trade Agreements Act. So the product is sourced from the U.S. or a designated friendly country.
I see. So that's for government contracts.
Government or high-security commercial jobs where you absolutely need to know the provenance of your hardware. It's a supply chain security thing.
Yeah.
So if we connect all these dots, the big takeaway here is pretty clear. This thing is a high-spec solution where you get extreme durability. It's submersible, corrosion-proof, temperature-resilient.
Right.
And you combine that with this extreme reach, 1,000 feet. All in this tiny, low-power package. It's engineered for true hostile environment deployment.
On that note, here's a final thought for you to explore. The source material mentions this alarm is powered by E2D5D16D. Now, we know those are NTI's environment monitoring systems. So the question is, what kind of sophisticated security architecture, what kind of system needs an alarm that has to be functional across 1,000 feet of cable in these extreme temperatures? Thinking about that might just change how you view protecting critical infrastructure